Let's see how to integrate this trigonometric function. What we can do is we can take this denominator and split it into both of those terms in the numerator. Okay, so it will look like I have sine cube x divided by sine square x cos square x, plus the second term will be cos cube x divided by sine square x cos square x. Cos cube x divided by sine square x times cos square x, and I'll put that entire thing in a bracket and I have dx, which is with respect to x. Before proceeding further, I can do some cancellations. I can cancel sine square x and I'll be left with sine x in the numerator. I can cancel cos square x in the numerator and denominator, so I'll be left with cos x in the numerator. Okay, so basically my integral will then look like I will have sine x in the numerator, so I have sine x divided by cos square x, plus I have cos x divided by sine square x, and I have with respect to x. All right. Now what I can do is this cos square x can be written as cos x times cos x. So basically I have that sine x upon cos x, which can be written as tan x. Okay. What do I mean by this? So basically I can write this as sine x divided by cos x times 1 over cos x. Basically, I just split that cos square x into two parts, cos x and cos x. Plus, I have another cos x over here, divide by, again, I can split it into sin x times sin x, okay, with respect to x. So now what I can say is this sin x upon cos x, this will be tan x, okay, and that cos x upon sin x will become cot x by trigonometric identities, and that 1 upon cos x we know is sec x, and that 1 upon sin x over here, that 1 upon sin x over here is nothing but cosec x. Okay, so basically that integral at this point will look like I have integration of, let me just create some space over here. My integration will then look like I have sec x tan x as the first term, okay, plus I have cosec x cot x as the second term, and with respect to x. I hope that makes sense so far. Now we can split that integral into both the terms. So I have integration of sec x tan x with respect to x. So give that integral to first term, and then give that integral to the second term. So I have integration of cosec x cot x with respect to x. Now we know derivative or differentiation of sec x is sec x tan x, which is why integration of sec x tan x can be directly written as just sec x. Remember, okay, integration of sec x times tan x is nothing but sec x. Why is that? Because differentiation of sec x is sec x times tan x, okay? And integration of cosec x cot x is minus cosec x, okay? So this can be written as minus cosec x, okay? Plus let's add the constant of integration. See, again, derivative of cosec x is minus cosec x times cot x, which is why integration of cosec x cot x is minus cosec x. And this is your final result. I hope that makes sense.